Hi, everyone. Thanks for the introduction. I'm representing the Erasmus University of Rotterdam and the Student Wellbeing Program, more specifically. And to start with, I want to tell you a little bit more about the challenges of today's students and how this project came about, where we're combining psychological science and technology to try to solve some of today's problems. So the transition between adolescence and young adulthood is a really tough period, and it's a period that's marked by big life changes. The brain at this time is maturing, and the onset of really common mental health problems like depression, anxiety, and substance abuse, they're all at their developmental peak. And if you're a student at university, then you have a lot of added stressors to this already really distressing kind of biological phase, because you have academic pressure, you have a new social environment, living independently. So all of these factors kind of make things worse. And actually the studies show that when students start university, their mental health declines considerably, and over the next few years, it only sort of approaches that baseline that they were at before starting university. University can be really, really tough on students. And in our own research at Erasmus University, we found that 61% of students last year had clinically significant anxiety symptoms, which is crazy. 40% were experiencing medium to high burnout symptoms, and a lot of students were also showing mild to severe depression symptoms. And this is a trend that we kind of see happening globally, especially the COVID pandemic that had a big impact on adolescents and young adults. And we're trying to sort of recover from that and hopefully get better than what it was before COVID as well. And to cope with all of these struggles and to kind of be able to emerge from university with like a bit of grace and composure, then students really need to be taught emotional literacy, mental hygiene, having a good set of personal skills, having the ability to adapt to uncertainty and to regulate their nervous system. But this is not really something that they are taught at university. And that's why at Erasmus, we set up the Student Wellbeing Program, because we want to put more of this focus, of this emphasis on well-being. We want university to be a place where the focus is not just on study success, but on student success. So how do you create students who are going to graduate and go out in the world and are strong and composed? And we're trying to develop a holistic approach to tackle this by focusing on 4 key pillars: prevention, detection, support, and referral. And to do that, we have a variety of projects. As you can see here, we're working with lecturers and student support systems. We're creating spaces on campus and spaces within the curriculum to have a focus on well-being, community building, and decreasing the stigma. And amongst all these projects, we have the digital tool for daily use called Vroom, which is what I'm going to talk to you a little bit more about today. So Vroom is the development of a digital tool, and we, before starting this project specifically, we talked to a lot of users, a lot of students. We had focus groups and interviews, and what we found was that students are quite reluctant to ask for help. So they want to solve issues by themselves as much as they can, but they lack the good strategies to actually do it properly. And they don't know when to reach out for help, because they think, oh, I'm stressed, but so is my friend, and this friend is depressed, and this friend is anxious. So why should I be the one to go get help, right? So when they actually do go to psychologists or the support system for help, it's already quite late, and it's even more difficult to treat. We also know that they are technophiles. They use technology already quite a lot for their well-being, and they also have a complicated relationship with technology, because their time is very precious. They have a lot of things competing for their time, and the information overload is something that you see a lot when you're talking about technology. But we decided that a digital tool would still be a great way to tackle some of these challenges, to be able to introduce this sort of preventive care, mental health care at university, because digital technology, first of all, makes this knowledge, scientific knowledge, very accessible. We can reach a large amount of students, it's scalable, and it really lowers the barrier to seeking help, because you don't have to actually go to someone and show your face. And it's immediate. Right? There's no waiting times. You can just use it whenever you need it. And we want to use it to kind of build the bridge between this informal kind of support to the more formal types of support, like the other psychologists or study advisors and things like that. So what is Room? Room is a library of interactive digital interventions for mental well-being. And that basically means that it compiles a lot of little exercises that take about 5 to 10 minutes. We don't want it to be too long, because we want it to be easily integrated in the daily life of students. And all of this is based in tried and tested therapeutic approaches. We're actually using a very multidisciplinary approach, working with 2 PhD students on the effectiveness and the testing of the actual psychological interventions, and also design PhD working on the transference of the learning and engagement. And we are working with Thoughtworks, who are providing their expertise in machine learning. And we're also working with a company specialized in serious game design, who also kind of created this calm and nice little aesthetic that you see in this presentation. And all of the exercises that we have, they sort of pull in a lot of different therapeutic approaches, because what we know from the literature, from the research, is that different therapeutic approaches work for different types of people, and also at different times. So even the same person might benefit and resonate with a certain therapeutic approach at one point in their life, and then not at all, 2 months later. And when we sort of put together all of these therapeutic approaches, we end up with a lot of content. So we have more than 30 exercises. And of course, we don't want to overload students, right? So we know from our research that students don't have a lot of time, and they have a lot of information overload. A lot of things are competing for their attention. So how do we actually not overburden the user and make it easier for them to find what works for them and when? To do this, we first have to learn a little bit more about the user. And we do that by asking some questions in the onboarding, by letting them do little EMAs, so mood check-ins every day. From that, they can get a sort of overview, and they can also see how they're doing over time, and they get a series of recommendations. From there, they can choose an exercise to do, and when they do another exercise, they're always able to evaluate at the end. So did they find this useful? Did they enjoy it even? And the app sort of records all of these interactions and what they choose to add to their room, and what recommendations they actually choose. So although this might sound quite straightforward so far, we have another challenge, because of course we're a university and we love challenges, and we hold ourselves to a high standard when it comes to ethics and to integrity. So it was important for us that we have a privacy by design approach when going into this project. But then how do you do recommendations right and also respect privacy? This is a question that Oege now is going to answer, the expert.
Yes, yeah. So we were asked by the university, like, can we help with this issue? So they want to do like the recommendations, so like this really large list of exercises can do, and they should be like narrowed down to like 3 recommendations at a time, and they should be tailored. So it'd be like, to the right student at the right time. We should give like the right recommendations that not only they will enjoy, that they will actually decide to use the exercise, but also will hopefully be helpful and the most useful exercise we can recommend. And like the main challenge is, so like was already like decided early on for this project, like this project should have a privacy by design approach, which means that all the user data should stay on the phone. So this is an app, all the users, it's about mental health, people, like users fill in surveys, and it's like, all this kind of sensitive data. So it was decided from the beginning, like all that data should definitely stay on the user's phone and never be shared with a central server. Which is very good, and I think is the right approach. And I think probably for a lot of you, you have these kind of use cases, like more and more so, like with the GDPR. There's a lot of privacy awareness now, and for a lot of use cases, like you don't even want the data anymore because you don't want to be responsible for having access to it, or you simply are not allowed to have access to it. So there's a lot of cases now where you have to deal with this privacy concerns. Which can also make it difficult to give recommendations, because for recommendations, typically how we do this, we can learn from a lot of other users, and then we can learn from other users which are similar to you, and then give like similar recommendations, which makes it hard if we cannot share data. So this was our challenge as well, and this was why we were brought in, because we like a challenge. And so these were like, so if you think about like this recommendation with privacy by design, it kind of brings like two big challenges. So the first one I discussed, so we cannot share data. So the user data has to stay on the phone, and we cannot send it to a central server, which is a problem because like for us data scientists, like our typically way of working is like working in Python in a central server, and send all the data there and then learn from it. And then we, build our models, and our model get better and better and get better and better predictions or better recommendations. So this approach will not work here. So also the algorithms we have, which kind of rely on this paradigm of sending all the data to a central server, those algorithms also will not work. So we need a new approach to an algorithm that's actually able to like respect user privacy. The other part is then is like this recommendation system. If you want to respect user privacy, it has to run on like where the data actually lives. In this case, on the phone, and in this case, it's an app that was developed in React Native with TypeScript. And has to run both on iOS and Android. So we have somehow our code needs to integrate with this. Again, like we data scientists are used to working with Python, might be a challenge here. So for the first part, like how do you deal with like not sharing any data with a central server? Luckily, we're not the first people who ever had this problem, and some very smart problem had to deal with this problem before. Namely, at Google, they faced the same issue around 2017, like for their Android keyboard, they wanted to learn like with keyboard suggestions, like when a user is typing, they want to make a suggestion, like you probably mean this word, or if you're typing this sentence, then like probably the next word is going to be this. Like how do we make that better? And as data scientists, like you make it better with like gathering a lot of data. When people make suggestion, they either accept the suggestion or they don't accept the suggestion, and then from the feedback over time, you can make a better recommendation model. However, they didn't want to listen in on the keyboards, so like they did take user data, privacy seriously here, and they didn't want to have a reputation like Google is listening to everything you type into your phone. So actually they didn't have access to this input data, but they still want to learn from all these users, like what is the best next word, especially for smaller languages. Like so, for example, for English, there's a lot of data available and like so much text internet, but for smaller languages, they should also work, and then there's not so much data available, so they could really learn from all the users actually typing in like some small language. So how did they solve that? They came up with a method that you have a model running on the phone itself. So the model that makes a suggestion for the next word is running on the phone itself, has access to whatever the user is typing, but these words are never sent to a central server. But this model on the phone is then learning by itself from this user's feedback. So the model gets better over time at recognizing what the next word is likely to be for a specific user. Maybe you notice this yourself, while you're typing on your phone. Like over time, your keyboard gets smarter at making recommendations for you. And then they still aggregated these model weights, so not the actual inputs, but the model weights that kind of make the predictions. And they kind of shared those weights, which do not contain any sensitive data, and then averaged them out. And this actually allowed them to kind of learn for small languages, what is a likely next word. So this approach they called federated learning, and they shared it with the world, like in a nice research paper. And the same approach is now also used, for example, with the clinical data, where you have like sensitive patient data in one hospital that you don't want to share to some central machine learning algorithm. But then you can use federated learning to learn from different patients in different hospitals without actually sharing any patient data. Or with robotics is another example where you have a robot driving around with cameras, and you don't want to share all the camera data with a central server, but you might still want to learn over time how not to bump into walls, etc. Okay, so this seemed very promising. So we decided also to go for this approach, or we kind of had to, because we had the privacy by design already baked in, so we didn't really have a choice. So this seemed to be the only feasible way. So one takeaway of this is this definitely adds complexity. So if you have a situation where you have some kind of recommendation system, which would be really useful because you have a lot of options and you need to narrow it down for your users, and privacy is important, probably you need some kind of federated learning, it definitely will add complexity to your system. So we both needed a model on the phone. So on the right, you can see the edge. So that's all the phones of the students. And we need some kind of model that's learning on the phone itself. And then we need another loop that actually aggregates that information to a central AI model in a way that doesn't leak any information of the user. So this is doable. It definitely adds complexity. So if you're thinking of starting this, be aware this will add complexity to your project. If you don't have a choice, you don't have a choice, because otherwise you're not going to have able to make recommendations. As in our case, it is getting better. There are more and more libraries that kind of implement this. They're still not that good, and a lot of them are not actually working on the edge yet, which brings us to the second issue I mentioned, that if you want to build a recommendation system that respects user privacy, the recommendation system needs to work at the same place where your data is, in this case on the phone. So we ran into this as well. So again, there are some solutions. We tried a bunch of them. We tried really hard to get it to work in different ways. Most of them failed until we gave up and decided, okay, if the actual app is written in TypeScript and JavaScript, even though JavaScript is not really meant for data science work, we as data scientists will discount the TypeScript world. And so we decided to re-implement everything we had written first in Python and C++, and just we couldn't get to work that way. So we rewrote everything in TypeScript. So this is again depending on your stack. For your app, you might have to rewrite everything in C++ or Swift or Scala. And again, do you have the data scientists available that are able to do this, that know both those languages and the data science work? So this definitely adds a challenge as well. So be aware of that before you get excited about our results here. Cool. So the good news is, so we developed this for this case in TypeScript, and we actually decided to open source our implementation here, so other people can use it as well. So it's just a simple banded implementation. It only has the learning component yet, not the federated part. But so if you're also working in React Native now, feel free to use our open source package. So we're excited that we're able to share this. Then just a little bit of recommendations on recommendations. So when you build this kind of recommendations algorithm, so these are really good at optimizing. So from user feedback, they will get better and better at making recommendations, and they will optimize whatever you tell it to optimize, which makes it really, really important that you really think hard about what you're optimizing. So and one of the issues here is not everything that matters can be measured, and not everything that you can measure can actually matters. So the most easy thing to kind of measure is does somebody accept the suggestion or not? So it's what often are called clicks. So does the user click on your suggestion or not? It's easiest to measure. Easy to optimize for. That's what Facebook does, but we also know that Facebook gets into these weird rabbit holes by optimizing for clicks and engagement, which might not also always be the best content. In our case, it's very important to us that we actually suggest like the best content. So we do a mixture. So we both learn to optimize for clicks. It is important, like students are engaged and actually make the recommendation, they will actually, you know, like follow and like. But then we also use the ratings to at the end of the exercises that the student leaves, like how much they like the exercises, to recommend them things that they would probably gonna like, and also things that they say are helpful. So we do a mix of these two, of these three, and this is kind of how we decide to structure the balance. But it's something that you really want to think hard about, like what are we optimizing and how can we measure what we're optimizing. And then you also have to think about really hard about like feedback loops. So like these models only learn about feedback loops. So again, this comes down to like what can you measure and what can you optimize for, and how can you make sure that you can close these feedback loops. So in this case, we have the clicks when either the user decides to accept the recommendation or reject the recommendation, and towards the end of the exercise, we have the liking and the helpfulness. And so we can feed that back into the model and learn. So you have to really think about like, what do we want to optimize and what are the feedback loops we can put in place. Then you can actually learn these recommendations on a given context. So in our case, like we can know we have a phone, so we can know all kind of things about the students in a context like the time of the day. We could check for the weather. We could check location if we wanted to. And also we have like a lot of exercise, a lot of interventions that have things in common, so we can define a lot of features there. So here also the recommendation is always just start simple with with a small set of features. So for the context, we just started like, okay, like there's probably a difference between during the daytime and evening, what people like and are want to do, and in the weekend or during the week. So that's what we used, and then the mood check-in. And the features for the exercise on the right. So like if you like, you know, one kind of mindful exercise, you might also like other mindful exercises. If you don't like breathing exercises and you have rejected all the breathing exercises so far, then other breathing exercises you probably also will not like. So this is kind of how we started out as simple as possible. I always recommend start as simple as possible. You can always add more features and more complexity later on. Okay, so that brings us to some happy user stories.
Yeah.
I'm happy to pass it back to Djameela.
So I won't read them out because I think we're sort of running out of time. But basically, just to say, we got some really nice little comebacks from the users saying that they actually learned to put these into practice, these interventions, and that it did them good. So that's good news for us. And for the main takeaways, and to wrap it up, we realized that mental health is a serious challenge, and that a digital intervention tool can be a very good solution for this digitally native generation. But when building a recommendation system, which is necessary if we want to streamline the process of actually getting the kind of help that you need when you need it, then you need to consider privacy. And when you are considering privacy, then federated learning can really offer some nice and useful solutions. And that's it. I think we don't have time for questions, if I'm right, if I'm looking at the time. But of course you can, write to us or write things in the chat if you have anything.